Welcome back. Today I'll show you the completed instrument panel and the switches that we ended up installing in the RV4. So here's how we did it. So here is the switch console that's going to be on the right side of the aircraft. I'll flip them individually here in a second, but essentially it's start enable. Turn 1 turns on the EFIS as well as the engine. There's an avionics master which control multiple things. Then the lights, a couple circuit breakers, carbon monoxide, and then lights for the dash. So starting from the left hand side, the start enable, that makes the start switch on the stick hot. There you see the back. I ended up changing out a couple of these switches, which I'll show you in a second here. But all this is going to lay on the right side of the aircraft, where kind of the right armrest is. So individually, that one's going to enable the start switch on the stick to be hot. The EFIS is going to turn on the GDU 460 and the engine. Avionics Master is going to turn on pretty much everything else. And then they got the taxi light, the landing light, one at a time. The next one is nav lights first, and then nav lights plus strobes on the second one. Then there's only 3 circuit breakers in the aircraft. So you have the alt field circuit breaker as well as a circuit breaker for each of the PMAGs. So you're able to pull those PMAG circuit breakers and test the circuit on the ground. And then carbon monoxide, I elected to put it down there because it does shine green when it's serviceable. Didn't really want it on the dash. And then on the far right side is just the cockpit light that's going to be underneath the dash there. And that clicks on and off, and then rheostat bright. So let's just show you the different type of switches. Here's the basic one, 1-2. When the switch is up or away from the terminals, you can see that it's active, and when it's down like that, then there is no connection on any circuit. And these just connect with quarter inch Faston push terminals, and there's a little locking tab in there. It's a really nice secure connection. It's actually quite difficult to get it apart. There are lots of different types of switches out there, so this is an example of one that would have screw-on terminals instead of the fast push-on ones. In this case, the number 6 screw to attach the wires. Now this switch here is actually a 1-3, so it goes on either way. So that way would connect the 2 top terminals, and then up would connect the 2 bottom terminals. And this is a type of switch that you would use if you wanted to switch a magneto or a PMAG, because when it's off, you actually want to connect those 2 top ones. So you could use a 1-2 switch and mount it upside down, but then the locking tab is different. Here's an example of a 2-3 switch. Just allows you to power more than one circuit with a simple on-off switch. So there we connect both of those and both of those. The top 2 terminals would not be connected. And then when it's off, you could actually connect those 2 bottom terminals and those 2 on the bottom there. Here's a 2-10 one, which has 3 on positions. This type of switch you'd use for like the middle position being the master, the up position being the master plus the alternator. So there you connect those 2 circuits, but when it's on, it's going to connect one of the bottom ones. So you connect one of the bottom ones. And then when it's all the way up, it's going to connect both of the bottom ones. So that'd be an example where you'd turn on one landing light at a time. And some momentary switches used for flaps or trim or push to talk. And the momentary is indicated by the brackets around the on. So this would be momentary either direction. You could use it as a push to talk switch, like I said, or flaps or trim. And it works the same way. When you pull it down, it's going to connect the 2 top terminals away from where you push the switch. This one here spring loads to the center, just like the last switch. This is a typical flap switch that you would use on a RV. Momentary springs back to the middle position, and to retract or extend the flaps, you'd have to hold it in that position. This switch is a little bit different. It is momentary one way, but then it does switch completely the other way. This would be an example where you'd go down flaps in segments and then you'd go all the way up flaps. That would be what you'd use on like a flat positioning system. So here's the G3X Touch with rotary dials on each side and then the push buttons in between and the data card in the center. So the completed panel has that 10-inch display, lights on the top, the switches on each side, and then the symmetry that you saw in the last video. The lights on the top, first one is the starter enabled, so as soon as we flip that green start enable switch, that's going to light up. Middle one is the actual starter engaged, and the right one, since we have an EarthX battery, is a fault light for the battery. On the left side, we have the ELT, which would be on if you wanted to trip it on the top, otherwise it's always armed, and then test it on the down position. And the elevator trim up and down, a momentary switch each way, and then the flap down and the flap up, and the basic spring load to the center. So you'd actually have to hold the switch down and hold the switch up to keep extending or retracting the flaps. Simple way to do it. On the right side, we'll show you the completed switches in a second here, but the first one is master and then master plus alternator, and then you have two ignition switches for the PMags, and then the right side is the boost pump. So just talking again the difference between these 1-3 and 1-2 switches. So for magnetos and PMags, in the off position, you're actually going to connect the two top terminals. You want to ground out the magneto to shut it off. Whereas a 1-2 switch, you're connecting the two bottom tabs. So you could use a 1-2 switch and flip it upside down, but then the locking tab would be in the opposite side. So there's the 1-3 switch connecting the two top terminals, and the 1-2 switch, when it's in the up position, is then going to connect those two bottom terminals. So that's an important distinction. When you're switching magnetos or PMags, you want to connect the two terminals when the switch is actually off instead of on. So the switch itself, there's a couple nuts. The first one I adjust kind of in the middle portion of it, and then install it with the groove facing down. And then there's a little locking tab that has a little nipple on the end that will then go into that hole that's drilled into the engraved panel to then prevent the switch from rotating. So that's why you wouldn't want to install a 1-2 switch upside down for the magneto, because then that locking tab wouldn't be in place unless you drilled it upside down. Then a lock washer, and then another nut tightened with a 9/16 inch wrench. And we tighten all the nuts so that they are flat at the top and everything looks even across the panel. And I like to use these colored boots. I typically use yellow for ignition, blue for fuel, red for master and alternator, and then black for basic switches. So there's what the finished panel looks like with the G3X and all the switches installed and all the boots and the right hand switches. So build yourself something, take it for a rip. We'll see you guys in the next one.